Hello, my name is Nur Fatiha binti Azmi.
Hello, my name is Tai Sin Ru.
Hello everyone, my name is Khadija Ramlan.
Hello everyone, I'm Shukri Afifi.
Hi guys, my name is Siddhartha.
Hi, my name is Mama Azri Ifan.
Hello, now I'm going to talk about energy balance for non-reactive and reactive systems. The steps of solving energy balance for non-reactive and reactive systems are presented below. The first step is to draw a flowchart and label it. Step 2 is to construct an enthalpy table for inlet and outlet component. In the table, we must write molar flow rates and specific enthalpy. Then, in order to determine the molar flow rates and specific enthalpies for the stream components, we have to write the equation for mass balance and energy balance in step 3. Step 4 is to find the specific enthalpy. For each stream component, we must find reference state and solve the enthalpy. Remember to apply either the heat of reaction or the heat of formation method for reactive system. Step 5 is to calculate the rate of enthalpy. And lastly, step 6 is to solve the energy balance.
The law of conservation of mass states that for any process unit, mass can neither be created nor destroyed, but it can change from one phase to another phase or converted into other form through reaction process. However, in the first law of thermodynamics or law of conservation of energy says that for any process unit, energy can neither be created nor destroyed, but it can change from one form to another form of energy. These two laws are very important, especially to be implemented in the acetone delivering strategy to the storage tank to minimize total energy loss along the pipeline. In product delivering strategy, some components must be considered to be used based on the two laws. First, carbon steel has been chosen as the material of the pipe because it has low surface roughness. Big diameter pipe be chosen because it will reduce friction factor. 45-degree standard elbow and gate valve has been chosen as fitting end valves because these two have the small relative K constant. For sudden enlargement edges, any edge characteristic will not affect the system. Lastly, for the sudden contraction, well-rounded edges has been chosen because it has the lowest coefficient loss in contraction.
Let's move on to the last part, which is storation of acetone. Acetone will be stored in a storage tank, so without further ado, let's discuss about the storage tank. The characteristics of our storage tank are as follows. Firstly, we will use well-ventilated stainless steel tank since they can endure fire for at least 30 minutes and are durable enough to withstand any damage. Next, the tank will be fitted with a pressure relief valve which protect the tanks from rupture or implosion by enabling the tank to breathe or vent. Third characteristic is our tank will be equipped with insulation material, for example a cooling jacket. And lastly, the tank is equipped with nitrogen blanketing to prevent acetone from coming in contact with oxygen. So our storage tank is made of stainless steel with a diameter of 4.73 meter and length of 6 meter. Since acetone exhibits thermal expansion with the coefficient of 0.00143, we will set the maximum capacity of the tank to 95% of its volume. So we can calculate the holding capacity of the tank by using the formula, which is volume formula, which is pi r squared, and the holding capacity is equivalent to 100.158 meter cube. And by assuming the production of acetone of our plant is to 20,000 tons per year, our storage tank can hold the acetone produced up to 4 days before it reaches its maximum volume.